Welcome back, learners. So as we have said before the ad break that you're going to be now diving into our first concept of the lesson, which is the metal carbonates. So what are metal carbonates and how are they formed? So metal carbonates, they are known as weak bases. So they form weak bases. That means their pH is above 7, but then closer to 7. So it could be like 8 or 9. So those ones are weak bases. And remember we said, the more you move away from 7, so going to 10, 11, 12, the stronger the substance becomes. So if the metal carbonates had a pH of 13, they would be regarded as strong bases. But then because their pH is approximately between 8 and 9, then they can be regarded as weak bases. Now, an acid and a metal carbonate neutralize each other when they react. So an acid and the metal carbonate, when they react, they neutralize each other. Remember, we're saying that the metal carbonates, they are bases. So when an acid and a base react, they are going to neutralize each other. Again, that is dependent on the strength of the two substances. Now, the general weight equation for the reaction is, so an acid is going to react with the metal carbonate to produce salt, carbon dioxide, and water. So the product between the reaction of an acid and a metal carbonate, there's three of them. So we have salt, we have carbon dioxide, and then we have water. So in this particular case, we can use hydrochloric acid as our acid, and then we can also now use potassium carbonate. Remember that potassium, it is an element, or rather a metal that is found in group 1, so we can use potassium carbonate. So that potassium is going to be reacting with a carbonate, and we do know that the formula for carbonate is CO3. So when potassium reacts with carbonate, it forms a potassium carbonate. So hydrochloric acid plus potassium carbonate will produce the potassium chloride and the carbon dioxide, and then lastly the water. So we can have a weight equation for this reaction whereby we say hydrochloric acid is or has the chemical formula of HCl that is going to react with the potassium carbonate, and that is going to be K2CO3, and then that is going to react to form the potassium chloride. So basically the acid is going to donate its hydrogen, and then the metal part is going to be now reacting with that non-metal part from an acid to form KCl, which is our salt, and then plus what's the other one? Carbon dioxide. We know the chemical formula for carbon dioxide is CO2, and then lastly we're going to have H2O. Now, we need to take note that this reaction is not balanced. How do we know? We need to make sure that on the left-hand side and the right-hand side, the number of atoms are going to be equal. For instance, when looking at the chlorine, for instance, we have chlorine on the left-hand side, there's one of them, and then also on the right-hand side, there's going to be one of them. So you need to make sure that the number of atoms of each particular element or atom on the left-hand side is equal to the number of atoms on the right-hand side. So with this reaction, we need to balance the reaction. So when we're moving on, we also need to know that, as we have said, the chemical formula for that reaction, we're going to have we had HCl, we had the K2CO3, we had the KCl, we had CO2, and then lastly we had our water being the H2O. Now to balance that chemical reaction, we inserted our two. Remember, when we are balancing reactions, we are using the coefficients, which are the numbers that are written in front of the chemical formula. So the 2 and the 2, which means that we have 2 molecules of HCl, we have 2 molecules of potassium chloride, so that this reaction can be balanced. By checking, we notice that on the left-hand side now, we are going to have 2 hydrogen atoms. We're going to have 2 hydrogen atoms because of these 2. And then on the right-hand side, 2 hydrogen atoms, 2 chlorine atoms, and then we're going to have 2 chlorine atoms there, 2 potassium atoms, and then 2 potassium atoms, 1 carbon atom, and then 3 oxygen atoms, 2 and 1, that equals to 3 oxygen atoms. So the number of atoms on the left-hand side are equal to the number of atoms on the right-hand side. So with that one, we can say that the reaction is balanced. So how does that happen? The acid is going to contribute to the hydrogen atom to form the water molecule. So the acid is going to donate that hydrogen that is in front of the molecular formula, which is that H there. Whereas now the carbonate is going to form carbon dioxide gas, and the remaining oxygen atom becomes part of the water molecule, because we know that the carbonate is CO3. and carbon dioxide is CO2. So there's going to be one missing oxygen when a carbonate reacts, when carbonate changes to carbon dioxide. Then that one oxygen atom is going to react with the hydrogen to form the water molecule. Furthermore, the remainder of the acid and the base combine to form the salt. So after the acid has donated the hydrogen, the remainder is going to be chlorine. And after the carbonate has reacted to form carbon dioxide, the remainder is going to be potassium. Then those two substances are going to react together to form the salt, which is our potassium chloride. So that is how the salt is going to be formed. And as you can see, the name of the salt is dependent on the acid and the base that reacted. Potassium chloride. We had potassium initially and chlorine initially between the acid and the base. So the remainder of the carbonate is almost always a metal. So the metal becomes part of the salt. So the remainder of the carbonate is always almost a metal. We can also have a non-metal carbonate, but then in this case, we have a metal that is a potassium, and that one is going to react or form part of the salt, which is our potassium chloride. If you know the name of the formula of an acid and the carbonate, then we can be able to name the salt that is being formed. So if we know the formula of the two substances that reacted, then we can always name the salt that is going to be formed. What do I mean by that? If we look at this reaction between a hydrochloric acid and the carbonate being the potassium carbonate, then we're saying that the salt is going to be a potassium and the chlorine coming from the chlorine acid. So therefore, that's going to be our potassium chloride as our salt. Then the carbonate being the lithium, and then we know that the sulfuric acid it is your H2SO4. Then the SO4 part is your sulfate, because the hydrogen, remember, is going to be going to be contributed by the acid. So therefore, our salt is going to be lithium sulfate. When the nitric acid reacts with sodium carbonate, then the sodium part and the nitrate part, because the nitric acid has a chemical formula of HNO3. When the hydrogen is donated, then you're going to be left with the nitrate part. Then that nitrate is going to react with sodium to form the sodium nitrate. And then the sodium carbonate again there, the sodium and the ethanoic and the ethanoate, because we do know that ethanoic acid, that's now a combination, or that's now a reaction between hydrogen, carbon, and oxygen to form the ethanoic acid. Now, all these reactions, they occur in the presence of water, so the salt formed remains dissolved in the water. So as we've said, this reaction, it doesn't happen as them being solids. They all occur in the presence of water. So the salt that is being formed there, it is going to be dissolved in that water. You won't be able to see the salt as it being a solid. It is going to be dissolved in the water. Now, how do we then predict the name of the salt? Now, all carbonates have a group of atoms made up of 1 carbon and 3 oxygen atoms. For example, we said carbonate is CO3. That's 1 oxygen. That's 1 carbon and 3 atoms of oxygen. And then the atoms in the carbon dioxide product, which is now the CO2, they originate from this group. So the atoms in the carbon dioxide, they are going to break or originate from this group. And then there's only going to be 1 oxygen atom remaining, as we have said, and then that oxygen is going to react with the hydrogen to form the water as the product. Now the acid donates 2 hydrogen atoms to this remaining oxygen to form the water molecule, as we have said. So the acid is going to donate the hydrogen, whereas the carbonate is going to donate the oxygen. Now, the combination of those two is going to give us the water. The remainder of the acid becomes the non-metal part of the salt. As we have said, whatever remains after the acid has donated its hydrogen will become the non-metal part of the salt. And then the remainder of the carbonate is almost always a metal, and then this metal becomes part of the salt. So that means our salt is going to have a metal part from the carbonate and the non-metal part from the acid. Now, if you know the name or the formula of the acid and the carbonate, as we have said, we can be able to name the salt that is being formed. So, before we go to our next concept, we're just going to go again for a quick ad break, and I will see you just after this.